Hello, ladies and gentlemen. We are starting a new unit on solving equations and inequalities. So what is an equation in math? Well, it's simply a math sentence that has an equal sign. For example, 5 plus 4 equals 9. That has an equal sign, so that's an equation. 6 plus an unknown number equals 9, also an equation because of that equal sign. 5 times 4 equals 20, an equation. And 6x, that means 6 times an unknown number equals 42. Those are all equations. So if we have inequalities, that means that you have a math sentence that has either a greater than, less than or equal to, or greater than or equal to sign. For example, these look very similar. The only difference is instead of that equal sign, we have a greater than or equal or less than sign. So 6 plus 3 is greater than 8. Almost said 9 because 6 plus 3 is 9. But 6 plus 3 is greater than 8. That's true because 9 is greater than 8. The second one says 7 minus 4, which is 3. 3 is less than 10, which is true. 5 plus 3 is either greater than or equal to 8. It is equal to. So this inequality is true. And then 6 times an unknown number is less than or equal to 42. So our unknown number would be a 7, right? Because 6 times 7 is equal to 42. Or if x was less than 7, that would also be a true statement. So the first question is 9 a solution to this equation? Well, if I substituted 9 for x and I wrote 9 plus 6 is equal to 14, is that a true statement? No, it is not a true statement. So the answer to this question is no, 9 is not a solution to this equation. It does say, though, is 8 a solution to this equation? So now I'm going to substitute 8 for x. So 8 plus 6, does 8 plus 6 equal 14? Yes, this is true. So is 8 a solution to this equation? The answer is yes. In fact, 8 is the only solution to this equation. Is 8 a solution to this equation? 2x plus 10 equals 26. Well, that means I'm going to substitute 8 for x. So I'm going to, over here, I'm going to substitute 8 for x. So 2 times 8 is 16, and does 16 plus 10 equal 26? Is this a true statement? It sure is. So the answer is yes. 8 is a solution to this equation. Is this inequality true? X is greater than or equal to 9 when x is equal to 7. Is 7 greater than or equal to 9? No, that is not true. So is the inequality true when x equals 7? The answer is no, it's not true. All right, what's next? It says, why is x minus 4 not a valid solution to the inequality 7x plus 5 is greater than 33? Well, let's find out. Why is this not true? Well, 7 times 4 plus 5 is greater than 33. Well, 7 times 4 is 28. 28 plus 5 is 33. So it says 33 is greater than 33. That's not true. It's equal to. We could make it true by adding greater than or equal to 33, but that's not what it says. So the answer is, why is this not a solution? I would say because of this statement right here, because 33 is not greater than 33. Oops, I forgot to make that one fly in, but that's okay. Which value or values from the set 25, 45, 55 make the inequality a true statement? All right, so let's try each one of these. numbers and see which, if any, or if all of them make this inequality true. So if I substitute 25 for x, so 25 divided by 5 is 5. 5 minus 2 is not greater than or equal to 7. This one's not true. So let's get rid of 25. Let's try 45. 45 divided by 5 is 9. And 9 minus 2 is 7. So is 7 greater than or equal to 7? Yes, it's equal to. So 45 is a true statement. I'm sorry, this box keeps getting in my way. I know you guys can't see that, but all right, let's try 55. 55 over 5 minus 2 is greater than or equal to 7. Well, 55 divided by 5 is 11, and 11 minus 2 is 9. Whoops, I said 9 and wrote 9. 9 is greater than or equal to 7. Is that true? Yes, 9 is greater than 7. So there's 2 of these that make this inequality true, 45 and 55. All right, Michael is planting seeds in his garden. Each pack of bean seeds costs $1.29, and each pack of pea seeds costs $1.39. He has already spent $7.99. Because he can spend only $20, the inequality, $1.29 times the number of bean seeds, so however many bean seeds we buy times $1.29 plus the cost of pea seeds, so $1.39 times the number of pea seeds that are bought, plus he's already spent $7.99, must be greater than or equal to 20. He wants to purchase 4 packs of each type of seed. Does he have enough money? All right, so if you have $20, that means you can spend $20 or less, right? That's why we have this less than or equal to sign. Because if you have $20 in your pocket, you can spend $20 or you can spend less than $20. However, since he wants to buy 4 packs of both bean seeds, we're going to make x equal 4 plus $1.39 times 4 packs of pea seeds. So y is also going to equal 4 plus $7.99. Is that greater than or equal to $20? Well, let's see. Where's my calculator? I forgot to bring my calculator, so I'll just use my little phone here. You guys are probably faster than me. So $1.29 times 4 is $5.16. So I have $5.16 plus $1.39 times 4 is $5.56. $5.56 plus he's already spent $7.99. We want to make sure this is a true statement. So $5.56 plus $7.99 plus $5.16 is $18.71. If you have $20, can you literally spend $18.71? Yes, because he's actually going to get some change, right? So does he have enough money? The answer is yes, he does, because he spent less than $20. All right, the next one says true or false. K is equal to 2/3. So is this so it's saying true or false? This is a solution to this inequality. So we're going to multiply 18 times 2/3 because we're substituting 2/3 for K, plus 4 is greater than 18. Well, I'm going to divide 3 and 18 by 3. 6 times 2 is 12 plus 4 is greater than 18. Well, 12 plus 4 is 16. Is 16 greater than 18? No, this is a false statement. Did I do that right, you guys? I think I did. 18 over 1 times 2 over 3 is 12 plus 4. Yep. All right, let's look at this next one. Let's say Sally's going to the mall and she says, hey, Mom, I'm going to the mall. Can I have at least $20? Well, how much money does Sally want? Does she want $15? No. Does she want $20? She'll take it. but really probably she wants $20 or more, right? She probably wants either $25 or $30. So the words at least means that Sally wants greater than or equal to $20. Sally wants X number of dollars, right? In inequality. So if Sally wants that this much money must be greater than or equal to 20. So the words at least always goes with greater than or equal to. Just think about how much money you want. If you say, Mom, I need at least $10, that means $10 or more, right? So then it says, give some values that would satisfy my inequality. So let's say Sally got $20. Would she be satisfied? Yes, that would go with what she said. What if Sally got $25? Is 25 greater than or equal to 20? Yep. What about 50? What if she got $50? Sally's a happy girl, right? She'd be very happy. What if her mom gave her $10? Is that going to make Sally happy? No, because 10 is not greater than or equal to 20. All right, so now it tells us that we're going to graph those solutions. So we're going to start with 20 here. So this will be 21, 22, 23, 24, so on and so forth. This would be 18, 19, 17, 16, so on and so forth. So we're going to start by graphing 20, and we're going to fill this dot in because Sally would take $20 or any number to the right of 20 on her number line. And that is how you graph that inequality. And I wish I could draw straight lines, but I can't. So if Sally would take $20, if part of our inequality is a or equal to sign, you're going to fill in this dot. And then you're going to point your arrow in whatever direction the rest of the solutions are. And we'll talk more about graphing next week. All right, so let's write some expressions with variables. Now, equations have equal signs. Expressions do not have equal signs. So it says Kevin buys 3 sodas every week. How can you represent the total number of sodas he would buy in a given number of weeks? Which that means we don't know how many weeks. So let's let X equal the number of weeks. So let's say we're talking about 3 weeks. How many sodas would Kevin have bought altogether? 9, right? What about 5 weeks? How many sodas? 15. What about 10 weeks? How many sodas would he have bought? So basically what we're doing is we're multiplying the number of weeks times 3. So since X is the number of weeks, our expression would simply be 3X. And X represents the number of weeks. Notice there's no equal sign. That's why this says expression and not equation. Jackson needs to purchase some shoes and socks. Shoes cost 3 more than what? 3 more than what? Twice the price of socks. 3 more than twice the price of socks. Write an algebraic expression, no equal sign, to represent the cost of shoes. Well, let's see. What do we know about shoes? We know compared to the price of socks, shoes cost 3 more than twice the price of socks. So let's say the price of socks is the variable X, price of socks. Because we don't know how much a price of socks are. But we do know that shoes are 3 more than. So more than means you take that number, throw it to the end. Remember that? Twice the price of socks. Well, how do I write twice X? 2 times X is 2X, and then 3 more than. And this right here, guys, represents the cost of shoes. That's what this represents, the cost of shoes. All right. The next one, let me erase this. Jim's basketball score this year is what? It's 5 less than. That means we take all of this and we stick it on the end, right? Less than means go to the end. 5 less than what? Half of Donnie's score. Write an expression that represents Jim's basketball score. Well, we only know Jim's score compared to Donnie's. We don't know Donnie's. So let's let D equal Donnie's score. So let's pretend D equals Donnie's score. So we're going to write half of Donnie's score. How do you half a number? You either divide it by 2, a number divided by 2, or you could multiply it by 1/2. Both of these are equivalent. Dividing by 2 and multiplying by 1/2 is the same thing. And then 5 less than that. 5 less than half of Donnie's score. These are equivalent. So this expression actually represents Jim's basketball score. I hope that makes sense. Let's look at Lily's situation. Lily wants to know how much money she has in her piggy bank. She knows she puts only dimes and nickels in her bank. Well, that doesn't seem like a lot of information, but we do know something about how much dimes are worth. How much are dimes worth? 10 cents. So let's say you have 5 dimes. How much money do you have? 50 cents. How do you know? You would multiply the number of dimes times 0.10. So we don't know how many dimes she has. So let's let D equal the number of dimes, because we don't know how many she has. And we're going to let N represent the number of nickels. We don't know how many nickels she has, but we do know the value of a nickel. Does that make sense? So however many dimes she has, we would multiply it by 0.10 D, as in times the number of dimes, plus she has some nickels in her piggy bank. And we know that 1 nickel is 5 cents. So 0.05 times N times the number of nickels. And that expression will tell us, if we knew how many dimes and nickels she had, we could plug that into our expression and we could figure out how much money she has. But since we don't know, that's all we can do. This is an expression that represents the amount of money in her piggy bank. All right, Jason bought a wallet for $14.99 and X number of shirts for $24. Well, how many wallets did Jason buy? It says a wallet. So he spent one quantity of $14.99. So $14.99 plus he bought some shirts. We don't know how many he bought, but we know that each of them is $24. So if we knew the number of shirts he bought, we would multiply the number times 24. And all together, this represents how much money Jason spent in total. Now, if it said Jason spent $56, we could say equals 56, but it doesn't. It doesn't give us that information. So that's why we're writing an expression instead of an equation. Kevin buys 6 candy bars every week. Write an expression to show how many candy bars he buys in Y number of weeks. Well, this is just like the first one, isn't it? We don't know how many weeks, so we're going to leave this as a variable. So however many weeks it is, what would we do with that number? We would multiply it by 6. So the whole expression is simply 6y. And that's all the information we have. All right, now on this screen, we're going to be writing equations. Equations have equal signs, right? So, and also on this screen, we're going to be solving equations. So look at the first one, some number plus 20. Now, when you see the word is or equals, that is always your equal sign. So some number, what does that mean? Any variable. We know what plus 20 looks like. And now we see equals is 55. Now we could actually solve for the variable by doing the opposite inverse. Okay, so let me get rid of this. How do you solve equations? You solve equations. To solve equations, you complete the inverse operation, which simply means do the opposite operation. Well, what do you think the opposite of addition is? The opposite of addition is subtraction, which answers our next question. Basically, what's the opposite of subtraction? Well, the opposite of subtraction is addition. So that's what we're going to do. We're going to do the opposite of the operation that we see. So let's go back to some number plus 20 is 55. So since I see plus 20, we're going to do the opposite of plus 20, which is minus 20. Thing about equations is that whatever you write on one side of the equal sign, you write on the other side. 20 minus 20 is 0. So we bring down x equals 55 minus 20 is 35. So we just found out what our variable equals, and we can only do that when it's an equation, which means it has an equal sign. All right, so let's solve these equations, almost that expression. All right, x plus 5. What is the opposite of plus 5? Well, the opposite of plus 5 is minus 5. Minus 5. I draw that line to help me remember everything I write twice. So 5 minus 5 is nothing. So I mark it out. I bring down my x equals 9 minus 5 is 4. So the good thing about equations is you can always check your answer. If x is 4, does 4 plus 5 equal 9? It sure does. So we know we're right. All right, let's look at the next one. Y minus 10 equals 25. What is the opposite of subtraction? The answer is addition. So I'm not going to write minus 10. I'm going to write the opposite. I'm going to write plus 10. So whatever I do to one side, I'm going to do to the other side. This cancels. Y is equal to 35. Does 35 minus 10 equal 25? Yes, it does. The next one. All right, I see 12 plus x equals 20. Well, I want x by itself. I'm going to get rid of this positive number. So remember, there's not a sign in front of it. It means it's a positive. I see a plus sign here, but really what I'm trying to get rid of, I want x by itself on one side of the equal sign. The only way to get rid of a positive 12 is to subtract 12, because I want to cancel out whatever's on the side with the variable. Well, 12 minus 12 is 0. So I bring down my variable. 20 minus 12 is 8. Does 12 plus 8 equal 20? Yes. Now, guys, I know you can do most of these in your head, which is fine, but as we go forward and when the problems get harder, you need to know the steps. So I would like for you to just make it a habit of writing down all the steps, because as the problems get harder, you're going to want to know how to solve them besides in your head. Okay. Now this time the variable is on the right side of the equal sign. So we want this variable by itself. So we're going to get rid of plus 6. What's the opposite of plus 6? We're going to write minus 6. So bring that down. This goes away. 6 minus 6 is nothing. Bring down our y. 10 minus 6 is 4. If we plug it back in, is 10 equal to 4 plus 6? Yes. All right, next, you find your variable. The variable's on the right side of the equal sign. What's happening to our variable? It's being subtracted. From it is being subtracted 7. We're going to do the opposite of minus 7, which is plus 7. We're going to do it to both sides of the equal sign. This goes away. We bring down x is equal to 23 plus 7 is 30. And we can check it. 23 is equal to 30 minus 7. Is that true? Yes, it is. Next one. Now this is when you can use your calculators. You have an N over D button in your calculator. If not, you have to remember those rules of subtracting fractions. So I see x plus 3/4. So that means I'm doing the opposite of plus 3/4, which means I'm subtracting 3/4. It won't let me write that far on my screen, but you guys know I'm going to write it twice. So this is gone if I wrote it all out correctly. X is equal to 7/8 minus 3/4. Remember, you can only subtract when they have common denominators. So I'm going to change my denominator to 8. That one's already an 8. What times 4 equals 8? Times 2. So I'm going to multiply 3 times 2 and I get 6. So x is equal to 7/8 minus 6/8, which is equal to 1/8. X is equal to 1/8. All right, let's look at these two last problems and we'll be done. Pam has 15 candies in her bag. Her mother puts another handful of candies into the bag. Pam counts all the candies and now she has a total of 27. Write an algebraic equation, that means an equal sign, to determine how many candies Pam's mom put into the bag. Well, it says Pam started out with 15, plus her mom added some, right? We don't know how many she added, so let's let X equal amount mom added or whatever. So we have 15 plus however many mom added. All together, we have a total of, total means addition, 27 candies, right? So we want X by itself. So how do we get rid of this positive 15? Well, we're going to subtract 15 from both sides. I like to set it up like a addition or subtraction problem. 15 minus 15 is 0. I'm left with X equals 27 minus 15 is 12. So Pam's mom added 12 pieces of candy. All right, and I think this is the last one. Christina, Candace, and Devin together sold 43 tickets all together. That means we're adding up something to equal 43. Christina sold 12 tickets. Candace sold 17 tickets. How many tickets did Devin sell? We don't know. So that's our variable, right? We're going to let Devin equal Y. How many tickets Devin sold equals Y. So Christina sold 12. We're adding all together means to add. We're adding 12 and 17 and Devin's tickets, which we don't know, but we do know that all of that equals 43. So we can combine these two like terms. So 12 plus 17 is 29. So 29 plus Y is 43. How do we get rid of this positive 29? Well, we're going to subtract 29 from both sides. I've ran out of room again, but Y equals, what would that be, 14? I think so. Yes, Devin sold 14 tickets. All right, guys, I hope that helped. It should get you through the week. If you need anything from me, please let me know and have a good day. I will catch you guys later.